Hello everyone, myself Chandrakant Gorad, working as a head of Department of Civil Engineering Diploma in Fulton Education Society's College of Engineering, Fulton. Today we will see the practical compression test on a metal bar. Here we are taking bar, aluminum and mild steel. This test is used to determine the compressive strength or crushing strength of the metal or bar. Before starting this experiment, we will see the theory related to this practical. First of all, compression. What is compression? When push type of force applied on metal, then it undergoes the compression. Also, all of you know some metal and bar having the strength. What is strength? The maximum stress carrying capacity of the any metal or bar is nothing but the strength. Here we will see the compressive strength, a material capacity that to withstand forces that tend to reduce its size by crushing or squeezing it is nothing but the compressive strength. Now we will see the materials or equipments required for this test. First is CTM or UTM. CTM means compressive testing machine and UTM means universal testing machine. In this test, we are using UTM of capacity 400 kilonewton means 40 ton, and we are using specimen metal bar of mild steel and aluminum having diameter of 16 mm, and at the same time length is having 3 times the diameter means 48 mm. Say UTM, it consists 3 parts: upper head, lower head and middle head. Upper and lower head are fixed and middle head is moving up and down. This upper portion is used for the tensile test. At the same time, that lower portion is used for the compression and single shear and double shear strength. Also, here is the monitor and digital display screen which shows the result of this test. Also, we are using specimen for this test, mild steel and aluminum bar having diameter of 16 mm and length 48 mm. Now, we will start the procedure. First of all, we will keep this mild steel bar at a lower portion by using this lower head. Now we will enter the data required for this test on this display. Test type is the compression. Customer name will select here SY Civil Diploma. Material type, first we are using the mild steel. That's why we will choose here mild steel and we will start the experiment. Here also we will choose specimen shape. Our bar is having solid round, okay, and here we will enter the specimen diameter 16 mm. Here we want to graph load versus CHT and they will accept data. We will get this screen, then we will say S. Here also we will enter SY civil name. We will save this. We will see this graph type. Now we will start the machine. Then we will stop and we will make the load tear. Means here our reading will start from 0 0. Again we will start machine and we will give the gradually load to this bar. Here specimen is failed, that's why we will stop the machine and we will get final result that load at peak having 141.460 kilonewton and cross-head travel 10.810 mm, and we will get compression strength is the 703.565 Newton per mm square. Now we will start the same procedure for aluminum bar. This specimen is break, so we will stop the procedure. Here we will get the maximum load 57.880 kilonewton. Crosshead travel at peak is the 7.680 mm, and we will get the compressive strength here 287.872 Newton per mm square. Now we will go for the observation table. Observation table involves serial number, specimen, dimensions of the specimen, cross-sectional area of the specimen, load at a failure, and a compressive strength. Here we have taken specimen mild steel and aluminium. Dimensions are same for mild and aluminium, having diameter 16 mm, 16 mm, length is the 48 mm, 48 mm, and by using area formula pi by 4 into d square, here d is the 16 mm, means pi by 4 into 16 square, we will get the 201.06 mm square. Area is the same for mild and aluminium as diameter is same. Also from UTM we got the failure load value 141.460 kilonewton, means 141.460 into 10 raised to 3 Newton. Okay. Also for aluminium we got the failure load value 57.880 kilonewton, means 57.880 into 10 raised to 3 Newton. And compressive strength value for mild steel 703.57 Newton per mm square, and for aluminium 287.87 Newton per mm square. Now we will check this same value by using the formula. Here we have taken for mild steel, we know stress is nothing but force upon area. Here P is the nothing but failure load. For mild steel, we know the failure load is the 141.460 into 10 raised to 3 Newton. We will write here 141.460 into 10 raised to 3 Newton. And area is nothing but 201.06 mm square. Now we will do the calculation. 141.460 into 10 raised to 3 divided by 201.06. It will give the 703.57 Newton per mm square. Same for aluminum. We got the value of failure load is the 57.880 into 10 raised to 3 Newton. We'll substitute here 57.880 into 10 raised to 3 Newton. Area here also same 201.06. Same here 57.880 into 10 raised to 3 divided by 201.06. It will give the 287.87 Newton per mm square. Now see the both values which obtained from the UTM and by calculation. Both are same. For mild 703.57 and for aluminium 287.87. From above calculation, we got the final result. Compressive strength of mild steel specimen is 703.57. 703.57 Newton per mm square. And compressive strength of aluminum specimen 287.87 Newton per mm. Now from above result we can conclude that compressive strength of mild steel is greater than the aluminum. Thank you so much.